we're going to look at identifying the key features of parabolas. Now, parabolas are the symmetrical U-shaped graph of quadratics. Those are the equations that have the x squared, like the trinomials or difference of squares that we factored earlier in the semester. They can open either up or down. So because they're a curved graph, they're going to have a direction of openness either up or down. They never open left or right. So here we have a diagram of a parabola. It's the blue U-shaped figure here. So it can open upwards like this, or it would open downwards and would be flipped over. There's a few key points that we need to know and be able to identify. The shape itself, again, is called a parabola. We have the Y-intercept, which is the same as in linear equations. We have x-intercepts, where it crosses the x-axis. They're also known as zeros. And then we have these two new values. One is the vertex, and the vertex is the highest or lowest point on the graph where the curve changes direction. So because the graph's opening upwards, the vertex is that lowest point on the graph here. If the graph was going the other way, the vertex would be the highest point at the top of the graph. It's also known as the maximum or minimum value, and that's the actual y value. So the actual y value of this point tells us the actual highest or lowest value. We also have this dotted line here, this red line. That's known as the axis of symmetry. The axis of symmetry is where the graph is split into halves, two equal parts that are symmetrical or equal to each other. And if you remember from elementary school, you may have used the red mirrors in math class where you'd put them on a line and it would mirror on either side. If you put a red mirror on this line, it would be identical on either side of the graph. And when we actually identify the axis of symmetry, what we write is x equals a number, and that number is the x value of the vertex. So let's look at an example of labeling some of those points. So here we have a graph. It's opening downwards. Here's our axis of symmetry, and we're going to try and identify some of those key points. So the vertex, again, is that highest or lowest point on the graph where it curves. That's right here, and the coordinates seem to be 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 and 10. And so the vertex is written down as a point. The axis of symmetry, if you remember, we said it was x equals a number. And it's the vertical line here. It's going through 1. It's the 1, the same as the vertex value. It's a maximum value because it's the highest point. And the value there is actually 10. So the actual maximum minimum value is 10, same as the y value of the vertex. As for the zeros, they're right here. Those are the x-intercepts. And it seems to cross at about 1, 2, 3, 4, about 5.5 to 5.6. Sorry, wrong spot. So about 5.6. And this one here appears to be at negative 1, 2, 3.4, and negative 3.4. These we don't actually write out as coordinates, and we normally just write them out as the values separated by an and. And finally, we have the y-intercept. The y-intercept's right here where it's crossing the y-axis, and that's at approximately 9.5. Now, if points do cross at these partway positions in between actual grid lines, I'll accept answers as long as they're fairly accurate. So if it was about halfway and you want to put 9.5, or if you put 9.3 or 9.7, I'll accept numbers within those ranges.